All right, there we go. Are we recording? We are recording. So I am going to do three, I think I copied three examples here to kind of help. No, we're still recording. And it still says I'm doing screen capture. Okay, I'll believe it. I don't know what shut off, but oh, wait a minute. Is my mic still on? Yep, my mic's still on. Okay, can you see that on screen? Yeah, you can. All right, here we go. Make that big. Super. All right. Remember, I have three choices for what I can do for cos 2 theta, right? Cos 2 theta can be this thing, or this thing, or this thing. Which one makes the most sense and why? The one that has sine, because notice sine's the other thing I have to kind of collect and solve. It'd be really hard to solve an equation that had both cosine and sine in it unless I was able to factor it somehow. We did see an example like that yesterday. But I think we're better off going to this one. So we are going to pick the one that is sine only. So I'm going to replace cos 2 theta with 1 minus 2 sine squared theta. And I had somebody yesterday kind of say, well, wait a minute, these formulas all involve alpha, not theta. It doesn't matter. You can call it whatever variable you want. So the variable shouldn't affect you. Okay, so there's step one. Step two, collect like terms. And that would be the negative 2 plus 1, which is negative 1. I don't like all these negatives, do you? No, let's multiply both sides of the equation by negative 1. All right, next step, does it factor? I think it does. I think if we open up a bracket here and we say 2 sine theta, and open up another bracket where it's sine theta, that takes care of getting 2 sine squared theta. Now, let me use a different color here. I have multiple colors. Okay, now I have to get plus 1 out of the number that goes here and the number that goes here. Well, I don't have much choice, really. It's either negative 1 times negative 1 or it's positive 1 times positive 1. Which one do I pick? I know it's the positive, and the reason I know that is because this is positive, right? So my final answer here is plus 1, plus 1. At least that's my final answer for the factoring. All right, what do I do with that now? Well, that means that 2 sine theta plus 1 equals 0, which means that sine theta equals negative a half, or sine theta equals negative 1. Okay, now I have to solve for those things from the interval from 0 to 2 pi. So where is sine of theta negative a half? Okay, I might want to kind of do this over here on scrap paper. I'll just move over here. So sine of theta is negative a half, and sine of theta is negative 1. Okay, where does negative a half happen? Well, sine is a half here at pi by 6, right? Because that has coordinates of root 3 over 2 and 1/2, right? And that's the one we want, right? Sine is that guy. Okay, so where is sine negative now? So I use my cast rule, and I go, oh yeah, sine's negative here and here. So I want the pi by 6 angle there and there. So what are those two answers? How much is it to get from there to there? That's pi by 6 past pi. So one answer is 7 pi by 6. Then what about the answer if I start and go all the way around to here? Well, in another pi by 6, that'd be 2 pi. So that's 11 pi by 6. So there's my two answers for this side of the equation. Now, where is sine of theta negative 1? Well, sine theta is negative 1 down here, and that happens at 3 pi by 2. So that's my other answer. And that's it. Those three answers are all we get. So that's the kind that we did yesterday. I thought I'd just start with one similar to what we did yesterday. Let's get tougher. All right, I'll pause the video. I'll give people again a chance to try this on themselves. Ooh, this one's got a tangent in it. And what tells me I need a calculator in this question? Just look at the instructions. Yeah, this is not going to end up being something I have memorized on my unit circle because notice it's actually telling you that it wants decimal places. So we're going to need our calculator for this. All right? All right, I'm going to pause my video here and let people in the room have a chance to try it, and then I'll start it back up in a minute. Okay, we're back rolling. Okay, so the first thing I got to do is collect like terms, right? So I'm going to minus tan x from both sides. So now I have minus 7 tan x, or tan theta, sorry, not x. Then I'm going to minus 3 from both sides. So I have 3. Then I'm going to divide both sides by negative 7. And it's at this point that I know for sure that I have to use my calculator, right? Because at this point it's like, well, what do I know that of tangents? Well, I know when tangent's 1 and negative 1, when it's root 3 and the reciprocal of root 3, and that's really about it. Oh, and of course I know when it's 0 and undefined. That takes care of everything I've memorized on the unit circle. So let's open a calculator. Now we have to be in radians. Don't forget we have to make sure our calculator's in radians. So that's exciting, clear that. So first thing we'll do is we'll go to the mode, and yep, we're in radians. Okay, so you might not have a calculator that looks much like mine, but it'll work basically the same. Remember how you do this? You drop the negative, remember that? Because often if you punch in an inverse tangent of a negative ratio, it'll give you a negative angle, and I kind of don't want that. So remember, the way I do this is I write it as, what's my reference angle? I'll even call it theta r. And yes, I'm deliberately dropping that negative. I'm deliberately finding the reference angle without worrying about a negative direction. So, and then my calculator won't come back. There you go. Inverse tangent of 3/7. Those of you with less fancy calculators, just go 3 divided by 7, then hit inverse tan once you got an answer. And you get this decimal, right? So 0.404, and how many decimals did it want? 3? 4. So 0.4049. I'm actually not really rounding it yet, but I might as well write it down in 4 decimal places. Okay, so I want 4 decimal places, so there they are. Now, where is tangent 0.4049 and negative? So I think I might make myself a little sketch. And okay, where is tangent negative? Well, according to the cast rule, tangent is negative here. So I have a 0.4049 angle there. And tangent's negative here. So remember, reference angle always goes to the x-axis, right? Remember that stuff? It's been a while since we did this. So how big is that angle? Well, I can find that angle by taking my calculator and going pi, thank you, minus, and I don't have to repunch anything. I can just hit the answer that I had before, so answer. And there we go. So I get, for my first answer, 2.737. So theta equals 2.737. Now that's only one answer, right? That's just this guy. Now I have to find this guy all the way around, and that would be 2 pi minus that answer. So here, I kind of don't want to round anything, so I'm going to just take this answer again and minus pi from it, or minus it from pi. So pi minus that last answer. There's that first answer again. Now I want to minus that from 2 pi. So I go 2 times pi minus that last answer. And that's 5.8783. 5.8783. Oh, wait a minute. I just realized I rounded that at the wrong place. 7367. That should be a 67. It wanted 4 decimal places. Do what it says or else you lose half a mark. There we go. Decimals. Any questions on how I did that? Okay, that one was actually really easy algebra-wise, and actually it didn't really need an identity, did it? You could have done one like this in chapter 4. Here's one that needs an identity. So once again, I'll pause, let people play with this, and then we'll come back and try it together. Okay, so if you haven't yet given this a try, pause the video and give it a try. Here's what I did. I realized that this cos squared x is kind of in the way. I kind of want to get rid of that. So what I'm going to do is I'm going to change cos squared. Since I know that sine squared theta plus cos squared theta is 1, I know that I can replace cos squared theta with 1 minus sine squared theta. So that's what I'm going to do. I'm going to replace that cos squared theta with 1 minus sine squared theta. Or in this case, x. I keep saying theta, but this one's an x. Now somebody might ask, well, how did you know to do it that way? Why not replace the sine instead of the cos? Well, because notice I already have a sine there. So it makes the most sense to make the entire equation sine. Okay, now what? Well, 7 sine squareds minus 1 sine squareds is 6 sine squareds. Okay, and then negative 4 plus 1 is minus 3. And now I've got a quadratic. And I'm going to try to factor it. Remember, to me, this is really just like 6x squared plus 10x minus 3. But can I factor it? Are there two numbers? Here's the way you remember this. You try decomposition. 6 times negative 3 is negative 18. Are there two whole integers that multiply to make negative 18 that would add to make 10? And let's see. My choices are 18 and negative 1. Nope. 9 and negative 2. Nope. 6 and negative 3. Nope. I'm out of choices. That tells me that I cannot do this by factoring. So this one I'm going to have to use the quadratic formula for. All right, so how does the quadratic formula work again? Well, it's on your formula sheet. Remember that the quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Oh, I have a question. Oh, from the fact that this is an identity that, the question, which I'm sure you couldn't hear at home, was, where did I get this, that I could replace this with that? Where is that identity? Well, the identity on your formula sheet of identities is this guy. And the fact that I know that that's true means any arrangement of these terms that's algebraically true must also be true. So I can take cos squared, right? I can take this thing and just rearrange by moving this to the other side of the equation. So I know cos squared must be 1 minus sine squared. There is another way you could think about it. Can I point out to you, if you don't like rearranging it like that, notice what I had was, I had 7 sine squared x plus, that's supposed to be an x. Sorry, that's terribly drawn. Plus cos squared x. Notice I could say this. Do we agree that that's the same thing? I can just say 7 of something is 6 of that something plus 1 of that something. Now, are you cool with that being 1? Right? So that'd be 6x, so that'd be basically 6 sine x squared plus 1, and then the plus 1 gets together with the minus 4. So there we go. Okay, so that's a good question. The other good question we had a minute ago while I had the sound and the recording off was, how do we know if we're doing this in radians or degrees? You know what? Always assume radians unless they tell you different. Radians is the default setting for trig at this level. So it doesn't say degrees, so we're going to do it in radians. Okay. So b is 10. And by the way, instead of x, I can say that this is sine of x. Sine of x is my variable here instead of just x. So sine of x is equal to negative 10 plus or minus the square root of 10 squared minus 4 times 6 times negative 3 all over 2 times 6. So the sine of x is negative 10 plus or minus, okay, I got to do some arithmetic here. 10 squared is 100, and 4 times 6 is 24. 24 times 3 is 72, and 72, and it's a minus a negative, so I might as well just say plus 72, right? The negatives cancel, over 12. So the sine of x is, and I get two answers here, right? Sine of x is negative 10 plus or minus the square root of 172 over 12. And I can feel good about myself. The fact that 172 is not a perfect square means I was correct in my assumption that this didn't factor. Whenever you break out the quadratic formula and you get a perfect square under here, you should always feel a little bit of shame because it's like, oh, this factored, I just couldn't figure out what it was. But 172 is not a perfect square, right? 144 is, 169 is, 196. So 172 isn't. And that's why this question said, break out the decimals, because this does not work out to whole rational numbers. Okay, so let's see what we can do with that. So I have two answers. So I'm going to break out my calculator. Calculator. I'm going to break out my calculator. I'm going to find out what the square root of 172 is. And then I'm going to, actually I don't really need to know what it is. I'll just do this as one calculation. I'm going to go open a bracket, -10 plus the square root of 172. Close the bracket for the square root, close the bracket for the numerator, divided by 12. So there's the plus answer to 4 decimal places. So sine of x is 0.2596. 0.2596. So there's one answer. And okay, let's just finish off that answer. Sine has to be a positive, right? Because it says that that's a positive number. So using my diagram here, I'll make a diagram up here. Where is sine positive, folks? In quadrants 1 and 2. So I have 0.2596 there, and I have 0.2596 there. Well, in quadrant 1, you are your own reference angle, so that's one of my answers. But my other answer I can get from going pi minus that number. So since I already have that number on the screen, let's just finish it off. Pi minus that number. And what was that number again? It was 0.259. So when I do that, it's 2.8820. Oh yeah, make sure you do this right. 2.8820. 2.8820. Oh, did I goof something up? Oh, right. That's not the final answer yet. Thank you. Somebody just pointed out, I forgot, I have to do the inverse yet. Oh, now I got to go back and erase stuff. Sine of x is this. Okay, let me go back. Thank you for pointing that out. Let me have a mulligan on that. So let me go back and get that decimal back again. So I'll just repunch. My apologies. Open a bracket, -10 plus the square root of 172, close the bracket for the square root, close the bracket for the numerator, divided by 12, equals, there we go. Oh wait, now I'm getting a different answer. Is that what you guys got? So open a bracket. I must have punched something wrong the first time. -10 plus the square root of 172, close brackets, divided by 12. Oh no, I must have punched something around the second time. So that's the same thing. Okay, I forgot. That's actually my ratio. I have to do inverse sine to that. So go back. I hate the fact that my calculator keeps disappearing. Inverse sine of that number. There we go. Oh, look at that. It's almost the same number. 0.2626. Actually, I've seen this problem before, and now I remember that number. 2626. That's right. So that's how big this is. 2626. That's how big this is. And I have to figure out how far it is from here to here by doing pi minus 0.2626. So my first answer is this. My second answer will be pi minus that first number, which is 2.8790. Careful there. 2.8790. If a question says round to 4 decimal places, you have to write that 0. You'd lose half a mark if you didn't, because you're not rounded to 4 decimal places. Same as like sig figs in science, right? Okay, so there's the first two answers. Where do I get the other two answers from? Well, notice, what have I done so far? I've done the plus part of the answer. I got to do the minus now. So I'm going to go, if I had a fancier calculator, I wouldn't have to repunch all this stuff. But all right, let's repunch. So open a bracket, -10 minus the square root of 172, close bracket for the square root, close bracket for the numerator, divided by 12, equals negative 1.92 blah, 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 blah. Okay? So let me just go back here for a second. Yep. So negative 1 point. Okay, so sine, oops. Ah! Let me erase that. There we go. So sine of x for my other answer is negative. That's how good my memory is. I can't remember what I just saw. 1.9262. Okay, so now I'm going to do this the same way I did the last one. My reference angle is the inverse sine of drop the negative, right? We'll figure that out ourselves. We don't need the calculator to help us because the calculator is probably going to steer us to a negative angle, and we don't want that. Come on, calculator, come back. Let's see, can I move you over there so you're out of the way? Perfect. So inverse sine. So you know what I'm going to do? I'm going to actually times this number by -1. There, and then I'm going to take the inverse sine. So I don't have to repunch decimals. I hate repunching decimals. Inverse sine of my last answer. Boom. Oh, it didn't work. How come? What is the calculator trying to tell me? Right, it's trying to tell me that sine can never be more than 1 or less than -1. So I can just go, I'll just say no solution. I was going to say undefined, but that's actually not true. You just say no solution. And the reason why there's no solution is, of course, that sine cannot be greater than 1, and sine cannot be less than -1. That's terrible symbols there, but you get the idea. And so from that, I know that there is, in fact, exactly 2 answers. Let me circle them or highlight them, and there they are. That's it. That's how you do that one. Okay, one more. Yep. Oh, is this one a general solution? Oh, yeah, you're right. Over the real numbers. So, okay. So I have one more step to my work. Therefore, x equals 0.2626 plus 2 pi k and, oops, 2.8790 plus 2 pi k, where k is an element, I'll use z, I'll be fancy, of integers. And that's my final solution. Whoops, come back. And that's my final solution. Having some problems with the pen here. All right, one more. Okay, same trick, everybody. I'll pause, give that guy a try. This one's got a different identity again in it. The last one I used sine squared plus cos squared as 1. This time I'm back to my 3 choices. I think, again, I'm going to pick the one with sine in it. All right, on your mark, get set, give it a try. Okay, we're back. So I'm going to replace cos 2 theta with 1 minus 2 sine squared. I keep saying theta, but these are all x's. Same. As long as you write it down right, it's all good. Okay, I think I'm going to move. It's a quadratic, right? You have a variable and then a variable squared. So the strategy for solving any quadratic is to move everything to one side and then see if you can factor. And if you can't, you got the quadratic formula. So I'm going to move this to this side. It becomes a positive, right? This one's already over on this side. It's not moving. And then I have a minus 2 on this side, but I have to minus 1 to get to this side, so it's minus 3. And I think that one does factor. 2 times -3 is -6. What 2 numbers times to make -6 but add to make -5? It's -6 and -1. So I need to make my factors have some combination that ends up at -6 and +1. So that tells me that whatever goes here and here has to become that -6. Or sorry, what goes here and here has to become that -6. So 2 times -1. So this is going to be minus 1 here, and this is going to be plus 3 here, right? Because then I'm going to get oh no, that doesn't work. Hold on. That doesn't work. Are we sure that this factors? It does. Okay, then what am I doing wrong? Oh, because I said this and then I wrote something else. Because that's the way I think. Minus 3 and plus 1. There we go. That's better. I said one thing, but I wrote something else down. That's better. So yeah, that works because 2 times negative 3 is the negative 6, and then 1 times sine is just sine, so negative 6 plus 1 is negative 5. So there we go. We're good. And I actually don't think I need a calculator for this one because sine of x would equal negative 1/2, and sine of x would equal 3. That guy has no solutions. Again, you could be fancy and say extraneous. I was saying that, reminding you of that yesterday. That's an extraneous solution. Doesn't actually work. This one, however, has answers. Okay, now this one I'm doing, again, all real numbers. So it says to 2 decimal places, but I don't need decimal places. Where is sine of x equal to negative 1/2? Sine of x is equal to negative 1/2 in these 2 quadrants, and sine is 1/2 in the pi by 6 family. So pi by 6 here and pi by 6 here. I guess I could do this as decimals. It does, you know what, I better do what the instructions said. Let's find the answers in decimals. So I think my answers are x equals, from here to here, that's 7 pi by 6, right? Plus 2 pi k. And this one is 11 pi by 6. I think we've seen this one already today, haven't we? 11 pi by 6 plus 2 pi k. But let's do this in decimals like it says. So I would take out my calculator and I would change this to decimals. So what is, open my calculator, clear everything else, 7 times pi divided by 6. So 3.67. So that's 3.67 plus 6.28k. I just happen to know that 2 pi is 3.14 doubled, so 6.28. And so that's one answer. And my other answer is 11 pi by 6. I don't know that off the top of my head. 11 times pi divided by 6. 5.76. It only wanted 2 decimals on this one. So 5.76 plus 6.28k. And there it is. There's my answers for that one. Okay, so there we go. Those are the kinds of questions you're going to see in the 6.4 homework. You can have the rest of this class to work on it. Tomorrow, all I'm going to do with you is a 6.4 ACC, and then I'll see if anybody has any questions from anywhere in Chapter 6, 6.1, 6.2, 6.3, or this one, 6.4. And then we'll spend maybe the last 20 minutes of class kind of introducing Chapter 7, because I don't think the test is actually all that long. Some people will probably finish it with loads of time to spare, so they could get going on the first Chapter 7 assignment. Okay, so there we go. I'm going to stop the video now.